Hello students, let's start lecture number 10.
Now let's learn theorem of areas of similar triangles. What theorem says? When two triangles are similar, the ratio of areas of those triangles is equal to the ratio of the squares of their corresponding sides. Okay, here we have two sentences. See this one comma is there, and in the first sentence we have two triangles are similar. Hence, we can take given triangle ABC is similar to triangle PQR. Here we have taken two figures, triangle ABC and triangle PQR, so that these two triangles are similar. This is given. Okay. The ratio of areas of those triangles is equal to the ratio of the squares of their corresponding sides. Now, this is what we have to prove. Hence, we can write area of triangle ABC upon area of triangle PQR. This comes from here. The ratio of area of those triangles is equal to the ratio of squares of their corresponding sides. Now, you have to know the one-to-one correspondence here. So, in triangle ABC and PQR, A is corresponds to P, B is corresponds to Q, and C is corresponds to R. So, AB is corresponds to PQ. Hence, if we want to take ratio of their squares, then we can take AB square upon PQ square. This is the one pair here. See this. AB square upon PQ square. This is one-to-one correspondence. Next is BC square. This is BC square upon QR square. Why we are taking square? Because here they have mentioned square. Okay. So square is mentioned here. So square of their corresponding sides. So BC square upon QR square, as those are corresponding sides. And the last pair is AC square upon PR square. So AC square upon PR square. This is the last pair. This is what we have to prove. Okay, so let's start with solution as a proof. Area of triangle ABC upon area of triangle PQR. Now, by simply looking this figure, AD is perpendicular to BC. That is also you can write from the diagram, which is also given. So AD and BC are perpendicular. PS and QR are perpendicular from another triangle. So we can use here, and you can take AD as a height and BC as a base. Similarly, PS as a height, QR as a base. So BC into AD upon QR into PS. This is what this step is. Okay, one half is cancelled because it is common. It is equal in both numerator and denominator. So actually formula, remember this formula, one half base into height. So one half cancel, and finally base BC, height AD, base QR, height PS. This is what this step is. The next step is equal to BC upon QR. We are separating this BC and QR and AD and PS. This is what our equation 1. In triangle ABD and triangle PQS, see this ABD. This triangle is ABD, and triangle PQS, PSQ, PQS. Okay. So here angle B and angle Q are congruent. Angle B and angle Q are congruent. How? Because of the identical mark. Or we can consider one-to-one correspondence. B and Q. All these two alphabets are placed in the middle. Okay, middle between A and C, P and Q. So B and Q are congruent. This is what given is because of identical mark. Angle ADB is equal to angle PSQ is equal to 90 degree. Now this is also we can observe here angle ADB and angle PSQ both are 90 degree. So we can write here. According to AA test, now we have two congruent pair of angles. So we can write according to AA test, triangle ABD and triangle PQS are similar. Okay. So this is what the similarity means. We can prove that using AA test of similarity. Now, if we know this, then we can write AD upon PS is equal to AB upon PQ. AD, PS, AB, PQ. These are again corresponding sides, and we can take their ratios. So these are the ratios of corresponding sides of similar triangle. Okay. So these are also congruent. This ratio is also same. This is one of the theorem we have already discussed it. So this is equation number 2. But triangle ABC and triangle PQR is again congruent, similar. I'm sorry, similar is there. So, but triangle ABC is similar to triangle PQR. Therefore, AB upon PQ is equal to BC upon QR. We can write from this statement. This is what the third statement is. So, if we consider this first, second, and third equation, finally we will come to the ratio of these two triangles. Area of triangle ABC upon area of triangle PQR, which is BC into AD upon QR into PS, BC upon QR, BC upon QR. Now, how BC upon QR is one more time? See this AD upon PS is what BC upon QR. AD upon PS is AB upon PQ, but AB upon PQ is BC upon QR. So AD upon PS is actually BC upon QR. So this AD upon PS is actually BC upon QR. Hence finally we can say BC into BC, BC square, QR into QR, QR square. And similarly, we can prove that AB square upon PQ square and AC square upon PR square. So this is what this theorem says, and this is what our desired result, because we have to prove that this corresponding side, the ratio of corresponding side, the ratio of squares of their corresponding side is equal to the area of these two triangles. Okay, this is what. Now it's time to solve practice set 1.4. So let's start it. First problem is the ratio of corresponding sides of a similar triangle is 3:5. Then find the ratio of their areas. Okay. Now we have ratio of corresponding side of two similar triangles. Okay. That is 3/5. And how to find their ratios of their areas and how to find it. The solution is consider. We have to first name. We have to give name for these two triangles, that is triangle ABC and triangle PQR, which are our favorite triangles, which are similar to each other. Okay. Now, if I take one-to-one correspondence, then AB corresponds to PQ, and I can write area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square. Why? Because theorem of areas of similar triangles. So, what is given is just a ratio of corresponding sides of similar triangle. That is, what we have is AB upon PQ is equal to 3/5. That we have. So, AB square upon PQ square is 9/25. Okay. Therefore, finally, the ratio of their areas, that is area of triangle ABC upon area of triangle PQR, is equal to 9 upon 25. This is the desired answer for this problem. In the second example, we have to fill the blanks. What example says, if triangle ABC is similar to triangle PQR and AB is to PQ is equal to 2:3, then find, then fill in the blanks. Here, area of triangle ABC upon area of triangle PQR is equal to AB square upon, here, you have to find corresponds, one to one corresponds. That is corresponding side PQ, AB and PQ. These are the corresponding sides. So we can write PQ square. Okay. But AB upon PQ is 2 by 3. Then AB square upon PQ square is 2 square upon 3 square. So answer is 4 upon 9. It's so simple. Third problem. In the third problem, if triangle ABC is similar to triangle PQR, area of triangle ABC is equal to 80. Area of triangle PQR is equal to 125. Then fill in the blanks. Here, area of triangle ABC upon area of triangle PQR is equal to 80 upon 125. And now we have to take, now we have to use the theorem, that is area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square. Which theorem is this? This is theorem of areas of similar triangle. Okay. So according to this theorem, we can write this. We can write only if these triangles are similar. Okay, these two triangles are similar, then only we can write this. This is what we learned in this theorem. Now, here area of triangle ABC is 80. So on LHS, we can write 80 upon 125 is equal to AB square upon PQ square. So let's write it. 80 upon 125 is equal to AB square upon PQ square. So 80 upon 125 is actually 16 upon 25, which is a reduced form. 25 5s are 125 and 16 5s are 80. So again we have to complete this step, and 16 and 25, if we take square root of this equation of this step, we will get 4 by 5, which is equal to AB upon PQ, and this is what the required answer is. Okay, so but see this, here they have asked AB upon PQ and we got AB upon PQ is equal to 4 by 5. So 4 by 5 is the answer. Example 4, triangle LMN is similar to triangle PQR. 9 into area of triangle PQR is equal to 16 into area of triangle LMN. Then if QR is equal to 20, then what is MN? Okay, here two triangles, that is LMN and PQR, are similar. First of all, write this. LMN is similar to triangle PQR. Okay, so now if they are similar, then according to theorem of areas of similar triangles, we can write area of triangle LMN upon area of triangle PQR is equal to, now see, they have given QR. Okay, QR is equal to 20. Already this ratio is also given in this in this equation. See this is one equation, and this ratio is given, so we can modify this and we will get this answer. But on RHS we have to write something which is from the theorem. Okay, now QR is given, so this QR is here and MN is the corresponding side of that. So according to theorem, what theorem says is MN square upon QR square. Now why I am selecting this pair only? Because QR is given and MN we have to find. Hence I am selecting this statement. These two sides only. Okay, these are the corresponding sides of these two similar triangles. Now this is what from theorem of, every time you have to mention this theorem. Theorem of areas of similar triangles. Yeah, similar triangle. Okay, but but what is given is this area of triangle element upon area of triangle PQR is equal to 9 upon 16. This is given. Okay, this is given. So if I give the number 1 and 2 for these two steps, then from 1 and 2 I can write mn square upon qr square is equal to 9 by 16. Now so okay, we will on both sides we will get mn upon qr is equal to 3 by 4. Now qr is 20, so you can write mn upon 20 is equal to 3 by 4. So by solving we will get 3 by 4 times 20, which is equal to mn. So 2 to the 4, 2 10 the 20, 2 1 the 2, 2 5 the 10. And the final answer is 3 5 the 15. So mn is equal to 15. This is the answer for this problem. Example 5. Areas of two similar triangles are 225 square centimeter and 81 square centimeter. If side of a smaller triangle is 12 centimeter, then find the corresponding side of the bigger triangle. Okay, this is the question. This is what the question is. Now, first of all, we have to consider their areas as A1 and A2. So, consider two triangles having areas. A1 is equal to 225 square centimeter and A2 is equal to 81 square centimeter. Also, S1 and S2 are corresponding sides of given pair of similar triangle. Okay, this is what the consideration. So, according to theorem of areas of similar triangle, we can write A1 upon A2 is equal to S1 square upon S2 square. Therefore, now we have the value. A1 is 225, A2 is 81. Now, S1 or S2, which is given? See this. Now, A1 has a larger area, means triangle 1 is large. So that side of the smaller triangle means S2 is given, which is a 12 centimeter. So S1 is not given, and we have to find that side only. Okay, so corresponding side of bigger triangle. So we have to find S1 now. So S1 square remain as it is, and S2 is given, which is 12. So 12 square we have to write. Don't forget to write square. This is crucial step. Now, by taking square root on both sides, we will get 15 upon 9 is equal to S1 upon 12. And by reshuffling this equation, I can write 15 by 12 upon 9. So 3 threes are 9 and 3 fours are 12. Again 3 ones are 3, 3 fives are 15, and 5 fours are 20. So 20 centimeter is the corresponding side of bigger triangle. Understand this? So we got S1 is equal to 20 centimeter, and finally we can write the length of corresponding side of the bigger triangle is 20 centimeter. This is what desired answer is. Example 6. Triangle ABC and triangle DEF are equilateral triangles. If area of triangle ABC upon area of triangle DEF is equal to 1 upon 2 and AB is equal to 4, find DE. In this problem, they have given both the triangles are equilateral triangle. Okay, equilateral triangle means what? Angle A, angle B, and angle C. All these angles have measure 60 degree. Similarly, angle D, angle E, and angle F are also 60 degree. So in triangle ABC and triangle DEF, angle A is equal to angle B is equal to angle C is equal to 60 degree, and angle D is equal to angle E is equal to angle F is also 60 degree. Now we have to take one-to-one correspondence. We can take any one-to-one correspondence anyway. So here I am taking A is to D, B is to E, and C is to F. So my one-to-one correspondence is A is to A, B, C. Let's write like this first. A, B, C, and D, E, F. Okay. Why I am writing here this? Because this is quite confusing, because all these angles are equal. So we can take first of all one-to-one correspondence. Now we have to take ratio of these two triangles, which is already given 1 by 2, and AB is given. So I can take AB, then I have to find DE. Like that my plan is. Okay. So area of triangle ABC upon area of triangle DEF is equal to AB square upon DE square. So I am writing D because I am considering A is corresponds to D, B is corresponds to E, and AB is corresponds to DE. Okay, this is according to theorem of areas of similar triangle. According to theorem of areas of similar triangles. Okay, so next step is LHS is given, that is 1 by 2, which is equal to AB square upon D. So AB square upon DE square. By taking square root on both sides, one can write 1 by root 2 is equal to AB upon DE. But AB is equal to 4, so DE can be written as 4 by, I'm sorry, 4 into root 2. Okay, this is what DE is. Therefore, finally, you can write 4 root 2 unit is the answer for this problem. Example 7. In figure, segment PQ is parallel to segment DE. Area of triangle PQF is equal to 20 units. See this PQ and DE, these are the parallel lines, and triangle PQF, this triangle, smaller one, PQF has 20 units area. Now PF is equal to twice DP. PF is equal to twice DP. Then find area of quadrilateral DPQE. DPQE. This much area we have to find using following activity. Now solution is area of triangle PQF is equal to 20 units. PF is equal to twice DP. This is given. Let us assume DP is equal to X. So we can write DP is equal to X and PF is equal to 2X. So entire DF is equal to what? It is X plus 2X. It is 3X. Okay. Next, in triangle FDE and FPQ series, FDE is bigger one and FPQ is smaller one. What we have to write is triangle FDE, angle FDE is congruent to angle FDE is congruent to C, angle FPQ has Y corresponding angles is comment, but let me write it first. FPQ. Okay, so I can write here FPQ because segment PQ and D are parallel. This is very important step, important thing. Hence we can write like this, and these two triangles are corresponding. These two angles are corresponding angles because of this given parallel. Similarly, angle FED, FED. Now this angle. Now this angle we have to say congruent to this angle. Earlier we write this angle, these two angles. These two angles are congruent because of corresponding angles. Now again we take this E and Q angles again from corresponding angles. So right here FQP, FQP. Now we will have two pairs of corresponding congruent angles. So we can directly state that triangle FDE is similar to triangle FPQ from a test of similarity. Next is area of triangle FDE upon area of triangle FPQ is what? FDE, this entire bigger one, upon FPQ. I can take here corresponding side, that is DF. Why I am choosing DF and PF? Because let me write it first. DF square upon PF square. See this? Here 3x square is given. So 3x is DF and PF is 2x. Hence we have to write this pair only. This is one of the corresponding pair of two similar triangles. So df square upon pf square. Now 3x square upon 2x square. So x get cancelled and 3 3 is a 9 and 2 2 is a 4. So 9 by 4 is the answer for this step. Now next step, area of triangle FD is equal to 9 by 4 times area of triangle FPQ. I am simply taking this equation, this and this equation, and simply reshuffling this. So 9 by 4 times area of triangle FPQ, but area of triangle FPQ is given. FPQ is given, that is 20. Okay, FPQ or PQF. This is the same angle. So I can write here 20. So finally, 4 1 are 4, 4 5 are 20, and 9 5 are 45. So 45 square unit, as it is square, as it is area, we have to take care of this unit. This is square units. Okay. Now we have area of this entire triangle FDE. FDE. See this. Also, we have area of the smaller triangle FPQ, which is a given. So this area is 20 and this entire area is 45. Okay. So by subtracting these two areas, that is 45 minus 20, we get 25 square units, and this is the area of this shaded this much region, which is I'm shading now. Okay, this shaded region is the area, 25 square units, and this is what quadrilateral DPQE. This is trapezium. Okay, because these two sides are parallel and these two sides are not parallel to each other. So quadrilateral PDEQ or DPQE is equal to 25 unit. This is the desired answer for this problem.